Hi guys, welcome everyone, and thanks for giving this stage to me. Firstly, good morning or evening, whatever as per your time zone. It's very confusing to me from last 2 days. Uh, so first of all, I would like to thanks DCG VR team for developing this awesome metaverse for us. It's really amazing, and they have really worked hard on every detailing I can see around, like the posters, the screen, the attendance areas. Everything seems fine to me. Now coming back to the topic, I'm going to present on modern DOS attacks with a few case studies which I've encountered during my research. So it will be a comprehensive guide that explores the various types of denial of service attacks and the latest technologies that attackers are using these days to attack the application, which can even evade the web application firewall. Okay. I'll start with myself by introducing my briefly. So currently, I'm working as a security engineer in Coldfit, better known as Cultfit. Where I mostly am leading the pen testing team and look around for the security in our web application or mobile application, basically on the application part. And my in my spare time, I used to hunt on organizations which has bug bounty programs and do my research work on those websites, especially. On social media, you can find me anywhere at Avi Unix handle. I use the same handle almost everywhere. Now coming back to the outline. Uh, Firstly, I just want to confirm that this presentation is ideal for all kind of security professional, bug bounty hunters, or anyone who is a IT manager or application developers who want to stay up to date with the latest trends in the denial of service attacks and learn very effective strategies for defending against them. Here the attendees will leave with a deeper understanding of modern DOS attacks and practical solutions to mitigate the risk of such attacks. So these are the outline where initially we will see some basic details and previous research done on DOS attacks like CP DOS and what are their kind. And then I will cover little bit of previously known application level DOS attacks. And then we will head on to the logical DOS attacks where I'll be covering a few case studies. Okay, so before start, we should, I guess everyone in our field must be aware of the denial of service attacks. It's like attacking third pillar of our CIA triads, like availability, which if you will see definition wise, then Wikipedia says that a denial of service attack is an attack where the attacker seeks to make a resource or any machine unavailable for the intended users. And if you'll see the definition from the CERT US, then they say that uh, the attacker simply flood the target or the targeted host or the network with a large quantity of request, bombard it, and simply crash the server. Both have their own perspective of seeing the denial of service attacks. But in application wise, if you'll see, then we can create a new definition, as we can see in the third para, like any functionality or any feature which an attacker is able to disrupt, then that should be considered under the denial of service attacks. So it's not like flooding a lot of requests or bombarding the request to server to crash down the machine or anything. So there should be some logical ways to do it. We will see in the coming slides. Before going those areas, let's see like what are the unintended DOS attacks and what are the intended DOS attacks. Simply, if we'll talk about the unintended DOS attacks, it's like not intentional to do the DOS attacks. Like we have seen that there was a website still there is the news website. That there was a this internet website where people can use post the news stories and used to do comments or like on that particular site. So if for some post it the post get viral, then it gets a lot of huge traffic to the website, and like application owner or the server does not prepare for it. Like I can get a hit of such large requests, so it will start consuming all the CPU uses, and it will crash the server. So it was not intentional, like people were not intentionally doing it to crash the server, but somehow it becomes a denial of service attack. Like it creates such attacks. Like so, to get rid of such things, such attacks, like we can simply increase our servers uh, resource value and get rid of those attacks. But then we have this intended DOS attacks, where here the attacker intentionally carry out the attack on the network, website, or any online resources that is legitimate, that is used for the legitimate users. So now at this moment of time, like attacker will intentionally try to crash down the server, so the real user or the legit user cannot be should cannot be able to use that site for even hour or some kind of like a month or a year or so. So now we'll start with the previous research that we have seen in the Hui Luigi and Hanhouse have previously presented on CPDOS attack in ACM CSS in 2019. So I'm just going to give a quick recap, like how these were working. So we will get some idea like about the application level DOS attacks. So here, uh, we everyone know that cache is what's the main purpose of the cache server. So here the main primary purpose is to increase the data retrieval performance by reducing the need to access the underlying slower storage layer. Like it will keep some of the common files onto the cache server and then serve it without going to the origin server every time if some user tries to request the same page again and again. So it comes like very handy for like reducing the time to like fetch some data, but still at the same time we got introduction of some vulnerabilities as well. So here in the cache poisoning DOS attack, we can see here that the in the first image we can see the first request user is just as an attacker here, the attacker is just sending the request with index.html URI, and given let me turn on the yeah. So here we can see that the attacker has crafted this request with the malicious header, x malicious header, and some value, and then send it to the trying to send to the server. So it will first pass on through the cache server, where it will see that I don't have any storage, like any record for this particular request. So it will again ask to the main origin server, like what will be the response for this particular request. So application will server will try to parse the request and try to generate a response for it. So it will see that there has been some malicious header, like which the server will not able to parse it. So it will send back error like a 400 bad request to the cache server. So cache server will again take a copy of it and keep it to itself and send the same response to the attacker, like in the fourth request you can see. So after that, like when a legitimate user is trying to get the same page index.html from the origin server from that website, so it will first hit to the cache server, and cache server will see that there is a response which has been associated with that URI. It will directly serve it to the legit user, which will show the 400 bad request. So here the client, the attacker has created that malicious request, and now this legit user is getting impacted for that malicious header just because of this cache server. So now, similar in a similar way, they have categorized this cache poisoning attack in three mainly category: header oversize and meta character, and next we will see. So, firstly, I'm going to cover HTTP header oversize, where you can see the concept is same. Here, the main problem is with the header size. Like, see. Mainly we can see that the HTTP request contains like a lot of information for the application server to understand, or the client to understand. So here, like in if you'll read the HTTP RFC, then you will not find any standardization for like uh, size of the request headers. Like what could be the header size? Like it cannot exceed the 10 KB or 90 KB or something. So this like creates a gaps between web server and a client. Like what exactly should be the standard size? It's like we can see that many web server like HTTP, Apache HTTPD provide a header size limit of 8192 bytes, and if you'll see around Amazon CloudFront CDN, then it provides 2480 bytes, 20 KB approx. So due to this non-standardization system, the HTTP request header size can be exploited to conduct a cache poisoning attack, which can lead to again denial of service attack. So here in the uh, first picture, we can see that the attacker is trying to put a header with a very large value and then send it to the cache server. I mean, he's just trying to send it to the origin server, but it will first face the cache server. So cache server will have a large number of the cache server has configured with accepting a large number of header size, but at the same time server is not configured for that much of lengthy request. So first, the cache server will not do anything. It will just pass on the same request, big header request, and send it to the main origin server. And origin server will not able to process it. So it will say that header size has been exceeded, and again send it to the cache server. And cache server will keep a copy of it and send it back to the attacker's machine. So at the same time, if next time any legit user is going to request for the same page, then he's start getting error for like 400 bad request. So this will like again causing with the same cache poisoning we have seen. The root cause was that, and with the oversized header, we can also create the same scenario. So for the envoy, we can see here I have kept around 90 more than 90 bytes of header size, and it shows that the 431 status code like request header size field too large. So now coming back to HTTP meta character, here we can see that the attacker is simply using special characters in the header and then passing on to the same to the origin server. So again, this cache server will not do anything, and it will simply send the same request to the server. Server will not be able to parse it and send back again with the error message. And same will be stored on the cache and send it back to the client. And if the legitimate user is trying to access the same thing, then they will start getting the 400 bad request. Similar to that, we have seen one more test case for that cache poisoning again, that we call HTTP method override. So here the problem was that like mainly most of the cache server, like any intermediate proxies or load balancer, does not provide some of the methods. Like they mainly were built to process the get and post request, but they were blocking like delete or put. So to overcome those restriction, like few framework have introduced a new header called like XHTTP method override. So if we will put that header in the request, then cache server will not do anything, but server will understand. Okay, the next request is for the post request, and it will again show you the error. So similar thing going to happen as we have seen previously. Like again, a copy of the response will be stored in the cache, and same response will be sent back to the client. So if legitimate user is going to request for the same page, then they will start getting 404 or 400 or some kind of bad request. So these were the previous research, and now we have seen some known application level DOS attack as well, like email bombing or Boolean love attack. In the email bombing, like attacker were sending a lot of emails by taking the advantage of the not rate limited on that particular request. For example, resetting the password or getting a sign up email. So they have sent a lot of emails to the victim and just consuming the resource. So these are the known attacks that we have already seen: email bomb and binary love attack, where it was one of the part of XXC attack, where the attacker were taking advantage of parameterized DDD and creating a lot of uh, parsing errors to the server and get denial of service attacks. Then we have seen the zip bomb attack, where we try to create a zip of a very large file with a similar character and then send it back to the server. And when server tries to decompress it, then it will just crash. And we have also seen some like uploading very large files. Uh, at some point, like it cannot handle the request of such large files, and it crashes. So now nowadays, a very good things we are seeing, like in the logical manner, like how attackers are using it. As we have seen many times, like long password or long string DOS attacks, where uh, I will going to cover all of these long password DOS attacks and some complex calculation, how the attackers are crashing the server, and some one test case I am also going to cover, like improper captcha implementation. And there was also a scenario where I have found a access control issue, that I have converted that particular access control issue to a denial of service attacks. So we are going to see that those one by one. So firstly, long string DOS attack, or you can see that here the attacker what they will do is just create a large number of like put the value of any parameter in the request with a very large number, like 10,000 or maybe 20,000 or 50,000, and just send the same thing to the server. And if that particular parameter is being used somewhere at the server side, and trying to do some process with it, like if we'll see at the time of sign up, many of the application uses hashing algorithm or any encryption kind of thing. Then at the server side, it will try to hash it or encrypt it. And if you are sending a large number of value, then again it will take a lot of computational time. So if you are doing same similar thing with the threading, then definitely it is going to crash the server, because it will not be able to process that. So to identify that, simply you can send a large number of value for any parameter and compare the response time. If the server is not responding properly, then definitely that's a kind of a denial of service attack again. So remediation we will see later on also. And I have attached a link for the HackerOne report. That similar kind of thing we have seen in the cloud Nextcloud, where the researcher was reported that they have given a large number of values to a password field, and the server was crashing. Then we are going to cover this complex calculation, like we have seen in many e-commerce website when we try to purchase any product. Then for single quantities, there is some MRP, and for if you are increasing the quantity, then the calculation will happen, and then it will show you the latest price with the like based on the quantity. So it's simply based on that. I have found the same thing in my during my research in my own company Culpit, where you can see here that there was a page where we can purchase a live products, that's a home workout, and the price of for for home workout was 1149. So when I was sending the request for a single quantity, then it was showing some like calculating at the server end 1149 for the quantity of one and into one, like whatever the quantity we are mentioning. And you can see here the response time of the from the server was 202 milliseconds. Now what I have done here is just increase the quantity, and while increasing the quantity you can see like again the server will try to uh, get the final MRP of that product by multiplying the number of quantity into the price of one product. So that in this case that was 1149. So when I've increased the quantity from 1 to 129, the response time become 431 milliseconds. Then I got a feeling like there could again be the denial of service attack if such calculation are being done at the server end. So again, I increased the quantity from like 129 to 129 and some value. So it will again, it is trying to calculate at the server end with the per quantity value, and it is again increasing the response time from 200 something millisecond to 1700 something milliseconds. So similarly, when I try to increase, the response time was keep getting increasing uh, in a like exponential way. So with this like attack, we can simply again send a lot of threads, not a lot of threads, but still few threads, and it will not understandable by the web server, like with the web application firewall as well. Like, is it a legit request or not? So it will send it again to the main origin server, and at the server side, when server is trying to calculate the quantity with the price, then again it will crashes. So that was another of kind, and then we are going to look at the improper captcha implementation. uh, Here I was auditing a website that was a government website, where I found that they have used captcha protection for brute force attack, but they were not using like Google captcha. They were using some manual captcha. So after like playing around, I discovered that the application was generating like sending a particular captcha request with some parameter t, and there was some random value associated with that. You can see here the URI. So when I was sending that request again and again, I was getting a captcha value, and that captcha value should be used with the uh, login form, like username and password. And if you are using like if you are trying to log in, and at the same moment when someone from other device or trying to log in, then the one who has requested the web login page recently will be able to log in, but at the same time when someone behind that timestamp will try to log in, then they will get a error. So uh, here I've taken a screenshot of how the scenario was working. So here we can see that there was a login admin panel where there is a three input fields. We can see email ID, password, and verification code. So the uh, process was very simple. The admin needs to enter the email address and password and verification code that we can see from the image. So uh, intermediate request, I have not taken the screenshot, but you can see the main screenshot for which the captcha was being retrieved from the server was something like at write write redata portal captcha images and some random dot gif with some value. So it was not meaning anything, like you can choose any value and it was responding the same way. So what I have done here is just trying put the throttle of 5 seconds and use the intruder to send the request. At the same time, when now the login was something like that when any user is trying to log in, like request that web page, they will get a captcha. And at the same time, when my attack is in process, then it will request for the new captcha. So if the for the previous user, that captcha start expiring, so it is of no use. So simply by writing this one liner script or two line of a script, you can see that I am just requesting this particular captcha URI for infinite time, and I can just put a slip value of 5 seconds or 3 seconds, and then it will again request for the captcha again and again, and no legit user will be able to log in. So here you can see here, like on this admin panel, I have given the correct username, email ID, and password with the correct value of captcha. But the server respond with please enter valid verification code, just because at the same time I have started my attack. And whenever like at the time when the legit user was trying to enter this captcha, that was expired already just because of my attack. So this again creates a denial of service for the user, like they were not able to log in into the portal because of this poor implementation of the captcha. So uh, now we are just going to cover the access control issues that which I have converted from it to denial of service attack. So similar to previous, again we have found something different way to create this denial of service attack. So I found this on a website which was looking similar to this, and we guys might have used WeTransfer application to send file from one computer to another computer, or from one individual to another individual, just a public sharing platform. So I found that there was an IDOR vulnerability and IDOR kind of vulnerability, and then it was also sequential in nature. So just by simple script I have created, which I'll be showing in the further slide. Anyone can stop the users from sharing any files through that website, and it starts throwing something went wrong. So you'll going to see that step by step how this attack was working. So here I'm just going to give you a functionality issue, functionality like how the website was working. Okay, so here we can see we got few options. Like first is drag and drop files, where you can upload the file which whatever the file you want to share, and then you need to put the email address of the receivers, like to whom the email is that file is going to send. Then your email address, whatever is your email address, then phone number, and after putting the phone number you need to verify it, verify the OTP for that particular phone number, and then click on share file. It will share the file. So here you can see that I have uploaded a file called testfile.txt and given the email address to the recipients, and my email address at the test@gmail.com, and my phone number, and and also the OTP, correct OTP. So yeah, as you can see here, even the website is asking for OTP. Still, there was a chance to create this denial of service attack. We will see it. So once you fill up all those details, you can see here that file transferred successfully. And on the receiver's email, you will see that receiver will get this email saying that get your files. And when you click on that file, the receiver will receive this test file.txt. So now the problem start here is uh, there was a vulnerability on that cross button, where like if user is just trying to upload a file and they have wrongly selected a wrong file, then there was a button of there was a cross button where you can just click on that and delete that file from the server. uh, okay, so when you click on that cross button, it generates a request to the server, and the request was looking something like this. uh, there was a URI for that removing the file, and there was a file ID parameter with some value. Like here we can see 489. So every time whenever you upload a file, we get a file ID, which either you can have seen from the inspect element or from the response when we were uploading the file. So on deleting that, I have seen that there was a file ID this, and then I try to again uh, send it to the repeater and try to play around, like what if whether it is like binded with some session or not. Then I send the same request, similar request again with all cookies and all headers removed, like whatever could have been uh, recognized by the server for any individual. So when I removed all those cookies and headers, still I can see that the server processed my request and given me the success. So here I confirm that it is not validating anything at the server end for any unique user or any individual user. So firstly, I try to get like confirm the IDOR vulnerability itself. Like I uploaded some file from another device and with another browser, and with the same file ID, I try to delete it from my from like let's suppose attacker's machine. Then I was getting a successful response. Then to escalate that from this access control vulnerability to like denial of service vulnerability, where my main aim was to like keep on deleting the files uh, in every 5 seconds if it founds any file ID, and then any user will would not be able to send the file across, so they will start getting error. So I've just created this script. It might not be visible, or you can just find the same script here. And I have done the here written down the flow how this script was working. So firstly, like upload. It was just here you can see the redacted.com remove share file function. So it was the main URI that you have seen here, and it was expecting some file ID in the body. And whenever we are sending that request, that file ID get removed from the server. So simply just you need to download this script and put like some file ID parameter. Like once you have to upload it here, then get a file ID from inspect element or from the response, and then with that script you just need to put the file ID here. What it will do is just create a range from that particular file ID to next 20 ID ranges, and then it will start sending one by one in a throttle of, let's suppose, 2 or 5 seconds or 10 seconds. And if it found any file ID, then it will again increase the count from next. I mean the next. Like here, let's suppose the file ID was 310, and it found a file ID at 310. Then it will, or the script will automatically readjust the ranges from 311 to 331. And I was doing the same thing with the thread. So the one function was sending the request in an increasing manner, and another function was sending the request in the decreasing manner to cache the file like as soon as possible. So once you will do that, then like here I have just run the script with the file ID, and you can see here whenever any uh, legitimate user was trying to upload a file onto the server, then this script automatically deletes that file. And the server the when the user fill up all the details with the even with the correct OTP and all, the user were getting error like something went wrong, please try again. So simply just by with this script, we have escalated attack which was simply vulnerable to IDOR, and that was escalated to denial of service attacks. So what was the impact here? As we have seen that we have just stopped all users to use that sharing functionality of that web application, and it was just making it unavailable for all users and saying the response as a something went wrong, please try again. So if we will talk about why such attacks are more dangerous than normal flooding or bombarding with a lot of requests. So you'll see here, like if in this request, we are just sending this request, and this is not malicious at all in any manner. Like no, with no web application firewall, you can detect that this is a malicious request, because simply you cannot protect any application from IDOR with a web application firewall. So simply this is just very hard to detect it. Then we have seen that the request was non-malicious. Then again, it was again will be not easy to detect by the firewall. And also, if you will come to know such attack like is being exist in our network, even though we understand that okay, this is the thing which are happening, but we cannot protect it from our end with the use of firewalls. So it's also a very big challenge to mitigate such issues. So what are the solutions for it? So as we have seen that no such hard code solution we can find. We can just simply validate the inputs which are being accepted at the server side from the client, and then we can just put a resource rate limit on any particular application. Like they cannot send similar kind of request again and again and again, so that can also be stopped. And the last method I would say for as a solution is just get a security audit done by the to avoid such business logic flaws like IDOR or some other kind of vulnerabilities. So with all those solutions, we can just try to improve from getting our web application availability and just get things done. Similar hypothetical scenarios, if we can see, like there are a lot of web application which provide account deletion process. So let's suppose they uses account ID kind of parameter, and that is vulnerable to IDOR. So any attacker can again create a script which is just sending that rotating the account ID and sending a request again and again. And if that application is has no access control, then that is just going to delete all the accounts from the server. So even if some user is trying to register a new account and try to log in, then again it will create a denial of service kind of attack. So no one will be able to log in inside that application. So such scenarios can be very logical, and it's hard to detect as a firewall perspective and stop it. So this was all from my end. If you have any question, then you can shoot up.
Feel free to ask any questions if you have for Abby. Thank you, Abby, for that excellent presentation. That was very creative attack methods you found there.
Yeah. Sure. So I'll take it as a no. And if you people from the audience wants to connect, then I'm definitely available with username same Abhi Unix anywhere on the LinkedIn, Twitter, or formerly Twitter, now X, Instagram, or anywhere we can connect it. And references I have attached here, and slides. I guess I will send it.